Hey y'all, here are the notes for lesson 7.5. I know on your paper in your packet it says 7.6, but hopefully you remember to cross that out and remember that this is actually 7.5. Um, so we're going to be talking about limiting reactant. I'm pretty sure that most of you already know what that is. We talked about it when you guys did your pizza puzzles on the tables last week or so, sometime in the last week or so. Um, anyway, and you all told me that you knew that the limiting reactant was the thing that you ran out of first, basically. But here's how you calculate that when we're talking about chemical equations and not pizza. Although we are first going to start out with an example with our graham crackers. If you remember from lesson 7.1, we started this whole concept of stoichiometry talking about s'mores and graham crackers. So we're going to continue on with that example. So basically what it says here is our problem. If you have 3,286 graham crackers, please don't ask me where you got that many graham crackers. I have no idea. But actually, if you want to calculate how the cost of 3,286 graham crackers using the current going rate on Walmart.com, I'll give you some extra credit. Email me the cost of 3,286 graham crackers. But evidently, we're having a big party, so we have that many graham crackers, and we have 512 marshmallows, and of course, we have as much chocolate as we could ever possibly need. So we have an excess of chocolate squares. And we need to know how many s'mores we can make. We're having this big bonfire. We need to know. It is important. So the first thing we do is to determine what's going to limit us is we find the mole ratio of the two reactants in question. So our two ingredients, reactants, that's the same thing as ingredients. We need to find the ratio between those two things. Before we do that, we need to look back and remember the equation for a s'more, which was 2 graham crackers, 1 chocolate square, and 1 marshmallow made 1 graham cracker, which is G2CHM. Okay, so that's the equation for a s'more. Look back in your 7.1 notes if you don't believe me, but I promise that's it. So we need to make a ratio from the recipe. We are not dealing with these numbers at all yet. This is a ratio just from the recipe. So we'll say reactant 1 is the graham cracker, reactant 2 is the marshmallow, and our ratio here is 2 to 1. 2 to 1. Okay? So that's the first step. Find the ratio. Step 2. Determine how many of reactant 2 would be needed to react with the amount given for reactant 1. All right? So reactant 1 is our graham cracker. It's our given. We have 3,286 of them. That's a lot of graham crackers. Anyway, so the next thing we would do is we would take our ratio and we're actually going to flip it upside down because 2 is the graham crackers and I need graham crackers to cancel out. They can't be next to each other. They got to be opposite each other. So when I do 3,286 divided by 2, I get 1643, I think. Marshmallows. This is now M because this is M. This is G, right? So in order to use up all of my graham crackers, I would need this many marshmallows. I do not have that many marshmallows. I only have 521. So I will run out of marshmallows way before I run out of graham crackers. So my limiting reagent is the marshmallow. I will run out of it first. We often abbreviate limiting reagent LR, just FYI. So I'm going to run out of marshmallows first. That is just what's going to happen. Next, I need to actually answer my question. So I was just figuring out the start here. Right now I need to actually answer my question, which if we look back says, how many s'mores can be made? So here's the steps for that. Once I find my limiting reactant, I now need to write the ratio between my product and my reactant. For this one, it's easy. We look back here. Product is 1, reactant is 1. So my ratio is 1 to 1. So there's my ratio. And then lastly, I set up my equation with my ratio. So if I have 521 marshmallows, remember I'm using marshmallows because they're limiting, they're going to run out first. And my ratio is 1 graham cracker to 1 marshmallow. That's super easy. I don't even need a calculator. So I can make 521 s'mores with my 521 marshmallows. Again, that was pretty intuitive. But of course, with the chemical reactions, sometimes it's not that easy. But those are the steps, and that's the process. So let's try this again with an actual chemical reaction. It should be on the back of your page. All right. So now my question is, what mass of ammonia can be produced in a reaction chamber that contains 1,000 grams of nitrogen gas and 150 grams of hydrogen gas? Again, if you look back at lesson 1.1, this is the same, or 7.1, sorry. This is the same equation that we used then, and it looks like this. Nitrogen gas plus hydrogen gas makes ammonia, NH3. But of course, we have to balance that. So I need to put a 2 here and a 3 here. Now I have 2 nitrogens, 3 times 2, 6 hydrogens, 2 times 3, 6 hydrogens. So now my equation is balanced, and I can move on to answer the problem. Just like before, my first step is to figure out my moles, right? So always my recipe is moles. So everything I do, I have to convert to moles first. So let's start with nitrogen. I have 1,000 grams. The molar mass of nitrogen, or N2 gas, is 28. That came from the periodic table. Look it up if you need to. And 1,000 divided by 28 is 35.7. So that is my moles of nitrogen. Now I can do the same thing with hydrogen. I have 150 grams. The molar mass of hydrogen is 1, but there's 2 of them, so it's actually 2. And so 150 divided by 2 is 75 grams. Or moles, sorry. Moles of hydrogen gas. All right, so now I can use my recipe because I have my numbers in moles. Step 2, my ratio of the 2 ingredients from my recipe is 1 for nitrogen, 3 for hydrogen. 1 to 3. That's my ratio from the recipe. Next, I got to figure out how many moles of reactant 2 would be needed to react with reactant 1. So reactant 1, I had 35.7 moles. And this is N2, right? And the ratio is 3 hydrogens to 1 nitrogen. And my answer is about 107 moles of hydrogen needed to react with my nitrogen. How many do I have? I only have 75, which means that hydrogen is my limiting reactant because I'm going to run out of it first. Like it says here, because I only have 75 moles of hydrogen, not the needed 107, to react with all 35.7 moles of nitrogen. The hydrogen is the limiting reactant. I will run out of it first. Now I can solve my problem, which is how much of ammonia am I going to make? All right. So my desired product, ammonia, my limiting reactant is hydrogen. What's the ratio? 2 to 3. I'm sorry, I'm not in the camera. 2 to 3. 2 to 3. So now that I have my ratio, I can just fill in the problem. Given is my moles of hydrogen, I have 75. The ratio is 2 over 3. That's the product, ammonia. That's the hydrogen. And then here is my molar mass of ammonia to convert it back to grams. 1 nitrogen is 14, 3 hydrogens is 3, so that's 17 grams in 1 mole. And when I multiply or add that all together, I get around 845 grams of ammonia 3 is how much I can make from what I have here, realizing that I'm going to run out of hydrogen before I run out of nitrogen.